Today we are going to be adding rational expressions. And so the first couple problems have the same denominator, and that's the key, is you've got to have the same denominator in order to add fractions together. And all rational expressions are fractions. And so when we're adding them, that's just like adding fractions. So let's take a look at our first one here. The denominators are the same. And so we can just count up how many of the numerators we have. We have 6x plus 4x. And then when we rewrite the denominator again, you keep the denominator the same, 5x squared. And so we just add up these two numbers on the top of the fraction. That makes 10x over the 5x squared. And then we reduce. And so we just take out the common factor, like here. The 5 goes into 10 2 times. Over here, this 1x here will cancel out one of the x's on the bottom, leaving us with 1x on the bottom of the fraction. And so we rewrite the answer as 2 over x. And that's our answer. So remember, when we're adding fractions, if you had 1/4 plus 2/4, you add up the number of fourths. So we have 1/4 plus 2/4 makes 3/4. So notice your denominator's not changing. It's only the numerator that you change. But in order to add the fractions, in order to count up how many fourths we have to have the same denominator. We have to have fourths. So on this one, we have the same situation where we have the same denominator. But this time we have expressions in the denominator that we need to reduce. And the first step is to combine this as one fraction since the denominators are the same. Well, you can't add t and 6 together, so you just add them, or you have them as separate terms there with the plus sign between them. And then you go ahead and factor. So we've got a t plus 6, can't factor that, but the t squared minus 36, that does end up factoring. And it factors to a t minus 6 and a t plus 6. And so from there we can go ahead and cancel out those common factors of t plus 6. See, those will reduce. So what we've got left on top is 1. So that stays on top. We've got the t minus 6 down below. And that's our answer. Well, the next one looks like the denominators are the same, but they're not. Notice how the x here is positive, and we look on the other fraction, the x is negative. Here the 10's negative, but the 10's positive over here. So what we need to do is we need to take out a negative. We need to change this, and we need to multiply it by a number so that the denominators are the same. And so the number I'm going to multiply by is negative 1. I'm going to multiply this fraction right here by negative 1 over negative 1. And when I do that, it's going to be an equivalent fraction, which means it will equal the original one, just be in a different form. So let's go ahead and rewrite what we've got left. We've got this 3 over x minus 10. And now this is a plus negative 9. Because negative 1 times 9 makes negative 9. And then when I multiply the negative 1 over this subtraction, the signs will switch. And so you see how it becomes a positive x and a negative 10. See, it matches what I have on that other fraction. And so from that point, we can go ahead and combine these two terms, right? This is one fraction. And when I combine 3 and negative 9, I get negative 6 over the x minus 10. And that's the answer. So this one, we have to do the same sort of thing. We've got to come up with that common denominator. So you look at the denominator, what would I have to multiply this denominator by so it's exactly the same as this one? Well, all it's missing is a 4. So I need to multiply it by 4/4. You see, 4/4 is 1. And when I multiply by 1, I'm not changing the number. So I draw this 1 around the 4 over 4 to symbolize that 1 times a number doesn't change the value. I'm just coming up with an equivalent fraction. So 4 times 3 makes 12 over 4p plus 7 over 4p. And when I add those two numbers together, I get a 19 over 4p. And that would be my answer. That's as far as I can take the problem. Can't combine anything from there. So there we have it. Well, if this were a 20, though, then I'd be able to reduce the fraction a bit, but in this case I cannot. So this next one, we look at these two denominators and they're not the same. But before we get excited and need to multiply this one by x squared plus 6x plus 5, this one by x plus 5, let's do this. Let's factor this denominator to see what factors it has. Maybe we don't have to multiply by as much. But when I factor this, I get an x plus 5 and an x plus 1. Those numbers multiply to make 5, add to make 6. Here I have an x plus 5, so I already have one of the factors. So I just need to multiply by the other factor, x plus 1. So I'll go ahead and do that. And so when I do that, I'll end up having to use this distributive property. Distribute that 4 over that x plus 1. So what I like to do is write this as one fraction, x squared plus x. So I just rewrote the numerator of this one. And then 4 times x is 4x plus 4. And down below, I've got the same denominator. So I just rewrite it. And now I'm going to write it in the factored form. The reason I do that is because once I combine this, I'm going to try to factor it and see if there's any common factors. So let's go ahead and collect some like terms here. So I've got this 1x and the 4x's make 5x's. So now I've got x squared plus 5x plus 4. And down below that, I've got the x plus 5 and the x plus 1. So now we can factor that trinomial. And so the way it's going to factor is two binomials. So it's going to be an x plus 4 multiplied by an x plus 1. And then down below that, we still have those two factors of x plus 5 and x plus 1. So you can see how we've got a common factor of x plus 1. Now those will cancel. And so our final answer is x plus 4 all over x plus 5. That's our answer. So again, the whole idea here is you want to be able to multiply first, come up with that common denominator, combine like terms, then factor and cancel. So over here, same sort of thing. Let's go ahead and factor to see if there's a common factor between these terms. So you see how 2 goes into each of these two numbers. And over here, 3 goes into each of these numbers. So when you do this, bring down your x, just rewrite your x, make sure the 2's on the outside, do the division, you've got a 2 times x minus 5. Over here, same sort of thing. Put the 1 on the outside, do the division, see what's left over. You've got an x minus 5. So now we see that there's a common factor of x minus 5 on the bottom of the fraction. So here we want to multiply this by the other factor that it needs. So this side does not have the 2 like this side does. So that's what I need to multiply it by. This side does not have the 3. And that's what I need to multiply it by. And so now we go ahead and multiply it straight across to see what we have left over. We've got a 3x. So 3 times x makes the 3x. Here we have 3 times 2 makes 6. So I have 6 times by x minus 5. Over here I've got the 1 times 2 makes 2. And down below I've got the 6 times by x minus 5. And so from this point, now we can go ahead and collect like terms. So 3x plus the 2 makes 3x plus 2 over a 6 times x minus 5. So now since we cannot combine any terms any further, 3x plus 2 does not have common factors. We don't have any more common factors down below. So I'll just rewrite the problem as 3x plus 2. And sometimes they'll go ahead and multiply out the denominator, 6x minus 30. So either one of these two answers would be fine. The next problem looks like it has a common factor, c squared. But this is not c squared on the bottom. This is d squared take away. You're taking d squared away from c squared. So on this one, you have to multiply by the other's denominator. And you'll have a problem like this on your homework as well, where there's no common factors, so you just multiply by the other's denominator. So again, this one does not have that c squared minus d squared. This one does not have the c squared. Again, the whole concept is to remember this is not c squared down here. This is d squared. You're taking d squared away from c squared. So here we have to multiply. Now, a lot of people make the error of not distributing, not multiplying. and then they'll end up with the wrong answer. So you've got to distribute the d over these two terms, the c squared times by this c. So here's what we've got now. We've got a c squared, actually c to the third power, because c squared times c makes c to the third. And then over here we've got a c squared d, and it's a plus because it's a positive d. And then we have the d times by minus d to the second makes a negative d to the third power. Down below, write this in the factored form. Don't multiply it out. C squared times by c squared minus d squared. Now this will end up factoring a little bit further because this is a difference of squares. So let's go ahead and take out the common factor that we see. Make the problem a little bit easier on yourself. So I see that this term has a common factor of c. Oops, it doesn't. Nope, I didn't see that. I was thinking this had a c, but it doesn't. So we don't have that common factor. So let's go ahead and just reduce this a little bit. And we've got the c squared minus d squared. And so we'll rewrite this as c to the third power plus c squared d minus d to the third. And down below we got a c squared, and then we've got a c minus d and a c plus d. This is a difference of squares, so that's the way that ends up factoring. So we could end up trying to factor this, but we see that there's no common factors between these terms. We saw that when I had tried to do it earlier. So what we can end up doing is either leave the answer in this factored form like this, because there's no common factors, we weren't able to reduce it, or we could end up multiplying this c squared over this difference. And so just be familiar that they might end up writing it in either of these forms, in this factored form, or they might end up multiplying these numbers together. And so the multiplying would end up leaving us with this, still have the c to the third plus c squared d minus the d to the third power. That's on top. Down below, you could end up, again, multiplying. We'd have c to the fourth minus c squared d squared. So either one of these two answers, I always like to factor as much as I can to see if there's any canceling that can occur. And the nice thing about leaving it in the factored form is if you do have to substitute this into an equation later on, it's already factored so you can see what ends up canceling if anything does. So those are the types of problems you'll see on tonight's homework. Good luck.